Hello and welcome. We're going to focus on estimating a population mean. Remember, when we are estimating, we're talking about trying to find the population mean. So let's say I wanted to know the average age of students at Napa Valley College and I didn't have access to every student. I would grab a sample and use the sample data to estimate what the actual population data is. Now, the confidence interval formula is always statistic plus or minus the margin of error. Well, the calculating the margin of error is different depending on what you're talking about. We've already done this for proportions. Now, when we're talking about means, our statistic is an X bar. And our margin of error is calculated by using this t critical value times the standard error, which is S divided by square root n. Standard error is basically standard deviation, except we're using sample data. So this is standard deviation using sample data. I have a little bit of a bone to pick with OLI because in this first statement where we have standard error, these are actually not accurate. This is standard deviation, not standard error. So if I wanted standard error, it was actually S over square root n. This is standard deviation because it's using population information. Same thing with p hat, or with proportions. P hat, 1 minus p hat over n square rooted is standard error. Now, margin of error here is using this 2. And the 2 represents our 2 standard deviations from 95% of a normal curve. Remember that we have in this normal curve, within 1 standard deviation, we've got 68%. Within 2 standard deviations, we've got 95%. And so we're using this rough value here to calculate, and that's what the T represents. It's a critical value, and we change it depending on our confidence level. The actual value for 95% confidence level is 1.96. If you were to use normal charts or to use StatCrunch to calculate what a 95% confidence interval is, they're going to use 1.96. And there are charts out there that tell you what each of the critical values are. Now, when you're talking about a T critical value, that depends on the degrees of freedom, which we're going to get to shortly. When we're creating an interval to estimate the population parameter, and remember that the parameter is either P or mu, depending on what problem we're talking about. We're talking about 90% confidence, 95% confidence, and again, this is going to use T with degrees of freedom, and we'll talk about that on the next page. X bar is the sample data, and P hat is the sample data. We're going to jump into our first question to learn by doing from page 167. And the question says, is smoking during pregnancy associated with premature births? And to investigate this question, researchers selected a random sample of 114 pregnant women who were smokers. And the average pregnancy length for this sample of smokers was 260 days. From a large body of research, it's known that the length of human pregnancy has a standard deviation of 16 days. And they assume that smoking does not affect the variability in pregnancy length. Now, I want to first check the conditions, and the conditions that we need to check are random and normal. And random is typically stated in the problem, which I highlighted above. Okay, so when we're checking conditions, we can say random as stated. And when we're checking normal, there's a couple of different ways that you can check normal. You can check normal by having a population that's normal, and it would say it in the problem, which it doesn't. Or you can check by having a sample size that's greater than or equal to 30. There's a third way we can check this, but OLI doesn't really focus on it. All right, so since 114 is greater than or equal to 30, we can use normal calculations. Okay. Now we're going to construct a 95% confidence interval to estimate mu. Remember that our confidence interval is found by taking our statistic, which is X bar, plus or minus. Since it's 95%, we're going to use that 2. We could be using 1.96. And then we're going to use standard deviation since we know it. They say that the standard deviation is 16 days. Our X bar is 260, plus or minus 2 times 16 divided by the square root of the sample size, 114. This gives us 260 plus or minus 2 times 1.4985. I don't like to round until I get to my final answer because each time you round, you're actually adding error into the problem, and we don't want to do that. Multiplying 2 times 1.49, we have 260 plus or minus 2.997. This is our margin of error. We then do 260 minus 2.997, and we get 257.003. I like 3 decimals, 3 numbers behind the decimal. And then adding, we get 262.997. Now they say, oh, we also want to interpret our interval in context. Well, we know that we are 95% confident that the interval 257.003 to 262.997 captures mu, the true population mean of what? Well, what are we talking about? We want to, in the question B at the top, it says, construct an interval for mu, the mean pregnancy length of women who smoke during pregnancy. So this is the true population mean of women who smoke during pregnancy. Now, part C says, let's also construct a 98% confidence interval and interpret our interval in context. Well, we're going to use StatCrunch to do that. I will show you that in a minute, but we get the interval 2 point, this is C. I'm going to get rid of this right here, and I'm going to say 256.514 and 263.486. And it's basically the same statement that we have above, except we change 95 to 98, and we change these two numbers to here. Okay, all right, we're going to revisit the confidence interval applet in StatCrunch, and we're also going to do the 98% confidence interval in StatCrunch.